Hi guys, it's the Sciencebarbie. Today we're going to calculate the inverse of a 3x3 matrix. Now we have matrix B here, and as you can see, it has 3 rows and 3 columns. And what we want to calculate is a matrix B such that if one multiply B with its inverse matrix, and this is interestingly also commutative, so I could also do B to the power of minus 1 times B, and as a result I will get the identity matrix. What is the identity matrix? That's what we see here. That's the identity matrix. We can call it I3 because it's a square matrix with 3 rows and 3 columns. In the main diagonal we only see 1 as entries, and in the rest we see zeros. Now that's the algorithm that we're going to apply is called the algorithm of Gauss-Jordan. German mathematician again, and 2 German guys. And what we have here is the initial matrix. You can see that here, that's B. And we write down the augmented matrix, but we have the initial matrix B here and the identity matrix here. Now we're going to do row operations, perform different row operations, so that in the end we're having the identity matrix here on the left side, and on the right hand side we're going to have the inverse matrix B to the power of minus 1. Now how are we going to reach this? First we see we need here a 1. We already have this here. Now this is like a nice guidance because this is how the right hand side of this augmented matrix should look like in the end. So we already have this here, and now we want to eliminate the first column here below the pivot element. And how are we going to reach this? Well, we're going to take the second row and add 8 times the first row, and for the third row we're going to add 2 times the first row, and you're going to see immediately what happens. So the first row is being untouched. It's 1, 0, minus 1, leave some space, that's 1, 0, 0, okay? Then the second row plus 8 times the first row. Minus 8 plus 8 is 0. Here 4 plus 0 is 4. 8 times minus 1 is minus 8, 1 minus 8 is minus 7. And now and that's the trick, these row operations are also applied here to the identity matrix on the right hand side. Okay, that's more or less the trick, because in the end we want to have the identity matrix on the left hand side. Okay, now 0 plus 8 is 8. 1 plus 0 is 1, 0 plus 0 is 0. Now the last row, we add 2 times the first row. Now, minus 2 plus 2 is 0, that's what we wanted to reach. 1 plus 0 is 1. And minus 1 times 2 is minus 2. Plus 0 is minus 2. Again here, 0 plus 2 is 2, because we multiply it 2 times, and the rest remains unchanged. Now this looks very nice already. Now we are here, okay? In this case, what we want to get is here a 1, because this is obviously the one thing that we would like to have. How do we get the 1 here? Well, obviously we multiply the second row by 1/4. So we multiply the second row by 1/4. I hope you can see this. The first row, in this case, remains unchanged. Okay? It's 1, 0, minus 1. Then we continue here. 1, 0, 0. Now the second row times 1/4. Okay, that's 0, remains unchanged, and also now this is not going to change. 4 times is 1/4. Here I have minus 7 divided by 4. 8 divided by 4 is 2. What a luck. Here we have 1/4, and in the end here we have 0. Okay, and now the last row. What do we want here? Here we have 1, right? And we want to subtract more or less. Here we want to have a 0, 2, right? Just skip one operation or make it easier. So what we do here is we take the third row, it's this one here, and we subtract the new second row minus the new second one. Why? Because 1 minus 1 equals 0. Attention, it has to be the new second row. Okay, but that's fine for us. We're not going to panic. So 1 minus 1 is 0. Oh dear, I think I'm going to use a calculator because I don't want to mess it up entirely. Okay, it's minus 7. Now we're here, it's minus 2. Can you see it's minus 2 minus, and here we are minus 7/4. It's minus 1/4. I could do it in my head, but in front of the camera I usually make some mistakes. I don't want to do this. Now here it's easy. 2 minus 2 here is 0. 0 minus 1/4 is minus 1/4, and 1 minus 0 is 1. Looking good. Great, isn't it? Because now here it already looks like this one here. Now here that's the last pivot that we want to have here. What do we want to get? We want to get a 1. So what do? We multiply the last row by 4. So let's say, okay, the last row, number 3 multiplied by 4. And what do we get? So definitely this is not going to change. So let's write this down. It's 1, 0, 0, 0, 1, 0. Now let's continue with the last row. We have minus 1/4 times, of course, then minus 4. It's not just, let's say, times minus 1. So it's times minus 4. I hope you can see that. Minus 1/4 times minus 4 is 1. Let's not forget the line here. Again, 0 times minus 4 is 0. Minus 1/4 times minus 4 is 1. And of course, here 1 times minus 4 is minus 4. Now, what about the rest? How do we get to the rest? Of course, here, that's a nice one. The first row here, we have minus 1. Here we have plus 1. So what we do is we add to the first row the new third row. Let's do this. To the first row, the new third row. So 1 plus 0, you can see it here, 1 plus 0 is 1, 0 plus 0 is 0. Now we're here, minus 1 plus 1 is 0. 1 plus 0 is 1. 0 plus 1 is 1. And 0 plus minus 4 is minus 4. Now, the last one is a little bit tricky because here we have to add to the second row plus 7/4 times the third row, the new third row, because minus 7/4 plus 7/4 is 0. And this is what we wanted to get. It's just now here to this row we have to add the 7/4 of the last row. 2 plus 0 remains 2. Okay, 1/4 plus 7/4 is 8/4. 8/4 is 2. And then we have here 0 plus 7/4 times minus 4. 7/4 times minus 4 is minus 7. Well, what a surprise, right? Okay, just to make sure. It's minus 7. And now, look, here we are. We have the identity matrix here. That's the identity matrix. And here, in this case, we have the inverse. It's b to the power of minus 1. And how can we prove that this is correct? Well, we use Falk's scheme and just multiply it, right? Okay, now that's the new matrix B. Let's write that down. It has 1, 2, 0, 1, 2, 1, minus 4, minus 7, minus 4. And here, that's the original matrix that we had. It's 1, 0, minus 1, minus 8, 4, 1, and minus 2, 1, 0. Yeah, so we can still see this nicely. And this is what we're going to do. We are applying Falk's scheme. We are calculating b times b to the power of minus 1. And we use Falk's scheme to do so. Okay, that's just to prove that this is really the inverse of matrix B. Now 1 plus 0 is 1. Now here we have 1 plus 0 minus 1 is 0. Here we got minus 4 plus 0 plus 4 is 0. Now we are here. Minus 8 plus 8 is 0 plus 0 is 0. Minus 8 plus 8 is 0 plus 1 is 1. This is 32 minus 28 is 4. Minus 4 is 0. Here we have minus 2 plus 2 is 0 plus 0 is 0. Minus 2 plus 2 is 0 plus 0 is 0. And here we have plus 8 minus 7 is 1 plus 0 is 1. Here we have the identity matrix again, I3, and therefore we say, okay, we found it indeed. Our matrix B to the power of minus 1 equals 1, 2, 0, 1, 2, 1, and minus 4, minus 7, minus 4. I know it's a little bit tricky, I have to agree, but if you do this, you will be successful.
Das war ein Mathematik-Tutorial der Sciencebarbie. Jedes Like und Abo des Kanals freut uns sehr. Für Feedback und Kommentar nutzen Sie die Kommentarfunktion.